Good morning. Today's lesson is on geometric sequences. So what is a geometric sequence? So we dealt with arithmetic sequences when you're adding or subtracting the same value over again to create a list of numbers. So with a geometric sequence, you're actually multiplying the previous number by a number over and over again. And that number that you're multiplying by is what's called the common ratio. So we have a general formula for this, which is a sub n equals a, and sometimes they say a1, r to the n minus 1. Well, a1, if you remember from arithmetic, is your first number in your sequence. Your r is your common ratio. What are you multiplying by each time? So if we look at these three sequences and we look at the first one, so we go 4, 8, 16, 32, and 64. So if you notice, we're multiplying by 2 each time. So that would tell me that my r value is 2. Well, then my a1, or my first term, is 4. So if I want to find the general sequence, it is an equals 4, and then times 2 to the n minus 1 power. And n represents the number of the term. So if we wanted to find the fifth term, we would plug in 5 for the n. On the next one, we have negative 2, 2, negative 2, 2. So if you look here, our r value, what they're multiplying by, is actually a negative 1. So if you have a negative r value, notice that they will switch from positive to negative. So our an in this case would be our first term, which is negative 2, times negative 1 to the n minus 1 power. On the last one, notice that our numbers are going down. So in this case, they're actually multiplying by a 1/2. So you might think that they are dividing, but when we talk about geometric sequences, we don't talk about it in terms of division, but remember, division is the same as multiplying by the reciprocal. So instead of saying dividing by 2, we're going to say multiplying by 1/2. So then our general sequence would be an equals our first term, which is 1, times 1/2 to the n minus 1 power. All right, so if we say a geometric sequence has a fifth term of 3 and a seventh term of 0.75. So that's saying that a sub 5 is 3 and a sub 7 is 0.75, or we can write that as 3/4. So find the first term, the common ratio, and the 10th term. So really we want to find our equation. So if we think back to what our equation is, we have an equals a1, r to the n minus 1. So a sub 5 is 3, so we could write that as 3 equals, we don't know a1, and we don't know our r value, but we know our n is 5, so it would be the 5 minus 1, which is to the 4th power. The next one would be 3/4 equals, and again, it's a1. And then we would have times r to the 7 minus 1, which is 6. So what we have to do is we have to set this up, and then we have to solve like you would solve a system of equations. So if we look at that, we could solve that top one and say a1 equals 3 over r to the 4th. So what we're going to do is we are going to substitute that into our equation. So we're going to start with 3/4, and we're going to say, okay, well, our a1 is equivalent to 3 over r to the 4th, and then times r to the 6th. So when we do this, when you have r to the 6th, this is like in the numerator, r to the 4th is in the denominator, subtract your exponents. That would give me 3 r to the 2nd equals 3/4. Multiply both sides by a 1/3. So then I have 1/4 equals r squared, and take the square root of both sides. So r is equal to, and we could say it could be plus or minus 1/2. Now, if you look at the terms that are given, they were both odd terms and they're both positive, so it could be either. Majority of the time when we look at something like this, we would think of the positive one. So if we do the 10th term and we write out our equation, well, we have r, but we don't necessarily have our first term. So we're going to assume our r value is positive, and we're going to say 3 is equal to a1, and it would be 1/2 to the 4th power. Well, 1/2 to the 4th power is going to give me 1/16. And our first term then would be multiply both sides by 16. So 45 plus a 3 is 48. So to find our general equation here, we would say AN equals 48. And it would be R, not R, sorry, it's going to be our 1/2 to the n minus 1 power. So if we wanted to find a sub 10 would be 48 times 1/2 to the 9th power. And you would just type that in the calculator. If you have any questions, please make sure you send me an email and I will get back to you as soon as I can. Have a wonderful day.